Hello. In this video we are looking at paper 5, probability and statistics for February-March 2022. And our first question here, we have two spinners. We've got a red spinner with those numbers and a blue spinner with the edges of these numbers. And it appears we have to find the sum. So eventually we have to find a probability distribution table or draw one. So let's do our sums out. So 1, 2, 2, 3, and minus 3, minus 2, minus 1, and minus 1, we'll find the sum of each. So I'll do them now. And after this, when we do our distribution table, we'll have the x value, which will be our numbers in green there. And we're going to find what portion, what percentage is actually being looked for in each part of the table. So here's our table now. So we've got minus 2, minus 1, 1, 0, and 2. Okay. And how many of each do we have? So we have 16 numbers altogether. So essentially it'll be fractions of 16. So there's 1 minus 2 there. We've got 3 of them. So 3 over 16, and then 5 and 5 for the next two, and lastly, whatever's left over, or 2 of them. Just make sure they all add up to 1, or 100% if you want. And that's how you do this. This is discrete random variables, just to make it clear for the next part. So we have variance questions in this course, but this one specifically is about discrete random variables. So be careful with that. We're not dealing with population or sampling or something like that. It's a different topic. So we're given the expectation, which is the mean, of 0.25, and we're going to calculate the variance now. So it's each of those numbers above, you square your x and you'll multiply it by the probability there. And we'll add them all together. That'll be the first part. So that e to the bracket x and the square outside of that. That's the first part we're doing now for each one. And then after we've done those 5 values, which is done there, we'll subtract the given answer. We've 0.25 given there as the expectation, e to the ex, not e to the x. Multiply them all out. You can use your calculator. You could probably do it in your head. And when you've done that, it'll be 20 over 16 minus 1 over 16. And we end up with 19 over 16. You can leave it like that. And that's fine. Or indeed a mixed number. Okay, on to question 2. Okay, so question 2 here is binomial. Sometimes you're not sure if it's geometric or binomial, but just check the number of trials, if there's a set number of trials. In this case, we've 7. So we've 7 trials. And the probability of success, as given, was 0.18. And often binomial will be like a coin flip or a number of items. Defective products in a factory, testing is often similar kind of things to that. So we're given those aspects and it's greater than 2 days. So we're going to do a kind of a 1 minus all of that. So greater than 2 means not 0, not 1, and not 2. So we put in our 3 parts there. And from there, make sure you put it in your calculator. You can do them all separately or you can put it all in one go. Just be careful and use your brackets effectively. The answer is 0.115 for that. So that was more than 2 days. And the probability of it. That's part A. Part B. So we're given 3 chosen 7-day periods. Okay, exactly 2, so 2 of. and at least 1 as well. So probability of something that's greater or equal to 1, that would equate to greater than 0. So again, we'll do this thing of 1 minus that. So 1 minus, and again, I'll do my binomial aspects here. I don't know what happened there, a little jump. Okay, back to it. 1 minus, and again, put in, it's just a formula. At this stage, this is exam practice. You will know these things, presumably. And again, when you get the answer here again, I think you're going to lead into another part so you can store it in your calculator. Now, next, we're going to have 3 trials, and we're going to have that answer. So, probability of greater or equal to 1 day. So, let's put that in there. And the probability we're looking for, so we'll say x, now y. Y is equal to 2. So 3 choose 2, the answer from the previous question squared, and then of course the probability of failure of that, take it away from 1, and you'll get your answer here. So 0.421. So for these kind of questions, you're thinking about the success, and again, also the failure part of it. Question 3, we have a lovely histogram. I'll have to draw this in a second. So we have 250 children. Okay, do your little cumulative frequency as well. You always have to check that anyway. I'm going to start there by just putting in our range. So we have to change our bounds because we've got gaps. So I'm putting that in at the top there in blue. I'll keep it in blue, and I'll also put it on the diagram there. So I'll go up in 20s. So it could be easier just to go up in the numbers you're given, maybe in some way. A lot of them are in the 5.5 bracket, so maybe it'd be easier to do it like that. I'm starting from 0.5. Choose your own adventure, so to speak, but just make sure it makes sense and it's consistent. Okay, there's our frequency density when you have the frequency divided by the class width. Of course, you know that from GCSE. And the classes are 30, 15, 20, 10, and 25. Okay, so on the left-hand side there, you can see on the y-axis, we've done the frequency density up to 8. So yeah, 2, 4, 6, 8, 10, if you will. And our range is on the x-axis. I'm going to just do the lines now. There's no point drawing it. I know that like just using these pens, I could get a ruler on it, but it's clunky. Bear with me if you're going to fast forward, then fast forward. I'll probably do it in a minute. We're nearly there with one of them anyway. So from 20 to 20, 30.5 there, 30.5. Next one goes up to 2, which is nice whole number, and it ranges from 30.5 to 45.5. So 45.5, you can see there that blue, furthest blue for the moment. Then 45.5 to 65, so in between. So 1/4 across if you want, from 60 to 80. And again, it goes up further, it goes up to 3.4. So remember what we're doing here, looking back at those numbers. You could probably organize it a little bit better. You could probably make your own table with the cumulative frequency and the frequency density in your exam. I just have to do this with a digital pen, so you'll forgive me. That's a bit wonky looking, but anyway, it's fine. This one goes up to 8.6. So let's make sure it's in between those limits of 65.5 and 75.5. Yep. Again, it's fine. My drawing's not perfect. You'll be much better doing it by hand. And we have, lastly, 1.8. So just below the 2 line there, and going all the way to the top 20. What was it? 100.5. Okay. Color them in. Color them in if you want. Part B in. So that's drawn there, yeah. Part B is what? A median. So if you had drawn out actually your cumulative frequency details, like it's just a small detail and you know it well, but it just assists you for the next part. So adding them up, so to speak. So the median is the middle number. So 250 divided by 2 is 125. And what do we have? 21 to 51. I'm going ahead of myself a little bit. 21 to 51 to 119, and then the next one. So the next one, it was 66 to 75 minutes. So 66. Sometimes things in centimeters. So in minutes there, that's the median class interval. Part C, the estimate of the mean is 61.05. That's less than the median. The median is greater than the mean. You can draw your graphs here. If you refer back to the skewness, so you have positive and negative skew. I'm trying to just demonstrate it. Yeah. Let's just say, of course, your median is the green there. Your blue is the mean. I should put in the mode. Just give me a second. 6.1 was our 61, sorry, was our mean, and 66 plus was our median. The mode should be the highest point there, so just it should be just there, like that. And so we don't care about the mode, but just that's that point. So the median is greater than the mean. As I said, it's skewed negatively, I suppose. Left skew. That's a feature of the distribution, and then being different. Question 4. Okay, normal distributions, our formula there for standardizing, so x minus the mean given and all over the standard deviation of 6. Find a probability of between these. So you're just going to do 2 of these basically, but you got to be careful about where they are. So 46 minus 55 over 6 on our Z chart, and then also 62. Do the same. Go into your calculator, go to your tables. And especially when you get negative numbers and things, just check the logic of it on a distribution graph. Normal distribution. So there we have our little graphs. Yeah, minus 1.5 and 1.5. So I think just like when you draw these things out, you can kind of see it, hopefully. I mean, you just practice these a few times and you kind of start to see that. And there we have it. Let me just check that again now. Yeah. And, you know, at the end of a question, often just, if you see it, you go like, the answer is 0.8 in this case. Does that make sense? Is it a majority? Like, should it be that large? You'll often see the logic of it with these kind of questions. I think, mostly, unless it's around the center, so then you can't, you know, it's not that clear. Okay, males to females. 25% of females were less than 36. Okay, let's put that down. And we can solve that. So we have 36 minus 42 all over a standard deviation we have to find. And the whole total is that's equal to 0.25. So let's put that together. And it will help you also to draw, again, a sketch. Because when you look at it, 0.25, and we're looking at less than. So we're going to say 0.75 is equal to what we actually achieved there. So Z is equal to minus 0.674. Is equal to 36 minus 42 all over our standard deviation, which we have to find. So multiply across there, and you'll get minus 6 is equal to that. So minus 6 is equal to minus 0.674. And plug in your calculator, you'll get the standard deviation. is 8.90. Three significant figures there. And that's question 4B. 4C is where we have to bring these two parts together in some way. So we've got the weights of the males and females. We'll do them separately. They're independent of each other. And we have to find the probability of both of them being less than 46 kilograms. So the male one gives us that specifically actually in the question. So from part A, you'd have that. I might focus on the female leopards for now. It's less than 46, so we have to do a calculation for that one. It's in part B. So A was the males, B is the females, and C, part C, is to do a kind of finding a probability of both of them. So less than 46. So 46 minus our 42 all over our new standard deviation. So 8.9. And calculate that. You'll get a Z less than 0.4493. You can draw a little picture if you want. I think that would be straightforward. So sigma is 0.6732. There we are. Okay. Okay, the male one now we've minus 1.5. Do it on both sides. So we got a 1.5. Z is there. Z is less than negative Z when it's minus 1.5. So 1 minus, this would be 1 point, let me rewrite that. 1 minus, rewrite it again, just looks a bit dodgy, yeah, 1.5. So 1 minus 0.9332, so we get a very small value there, 0.066, and multiply that. You want to find both for, so males and females are less than 46 kilograms. You've two values that we've found there for that, multiply them together, and you'll get 0.0450. And that's question 4. That's a pretty hefty question, actually, in fairness. Question 5 are beloved permutations and combinations. So we just always check our details. This is a kind of different subject, almost subtopic to a lot of these, in that it has things you can recognize even outside of maths. So we have there are adults, so there's 5 adults, so there's one of them, and there's 7 people left, children, boys and girls, and so we only want 4 of them. You can kind of almost see the simplicity of it, but it's not that easy. When it comes down to it, there's 5 people altogether, so you kind of just do a kind of a set of lines here, like I'm going to do a few of them there. So boys and girls, boy, girl, this kind of stuff. So we have 2 boys we need in each one, and we need at least 1 girl. So boy, girl, and then fill in the rest. So how you fill it in is, you can just leave it, I suppose, but I'll put in A for adults. I think I'm going to need 5 of them, of course. So let's do that too. So 2 boys for each group. Again, you can see what I'm doing now. I'm going to go boy, girl, and then adult. Next one, boy, girl, then adult. And keep going. So boy, girl. Let me just check it. Yeah. And then lastly, girl, I suppose. If that makes any sense, just you can go back, you can check this, you can kind of see it. It's kind of it's got a kind of a real world validation the way we do these things. Although the calculation that comes up next maybe isn't so easy for anyone who can kind of still grasp it, even though you might not be in grade 12. And of course, why would you be watching this video if you're not in grade 12? But anyway, you can tell your younger brother if you want. You know the way it works. And just putting out these bits. So you're always thinking of, like, you know, what you can choose. I have 5 altogether and I want 2, so 5 choose 2. In these cases we're doing out of 3, out of 4 and out of 5 in that order for the boys, girls and adults. And of course, just add them all up at the end and you get 248 ways of doing that. Part C, we've some people, so let's write them out again. Again, you're doing dotted lines. I tell all the students, just do this anyway, even if you didn't actually need it in the end. So we've 3 boys standing together, which would be 1 object, and you've 2 adults at each, an adult at each end of the line. So there we go with the adults, and we just put in boy, I suppose. And that's it. So you've 2 adults, so you've you've got them in a specific place. So it's 5p2 on your calculator, permutations, times 3 boys, so 3 factorial, and then whatever, I think there's 8 left. So 4 million. So you can use your calculator here if you don't mind to find that. That wasn't too taxing actually, I don't think. Anyway, okay, a factory question. Again, just on site, it can be either geometric or binomial. You need to check it. So we always think about it whether it's fixed trials or not. So geometric could be infinite trials or beyond a number that we're expecting. So we have lemon we're looking at now, and we want to choose the 7th. And we just look at lemon now as the first thing. So it's 1/5 in terms of its ratio there. So 1/5. So we're going to do kind of like success times failure. So 1/5 times 4/5, and to the power of 6 there. That's our formula for this. When we're finding probability for geometric distributions. For the next one, again, you'll have lemon flavor, and at least, so more than 6, as I wrote there. You can do your 1 minus p. Again, we're dealing with p's and q's here. You're dealing with your p's and q's. But q, just on its own, there, q to the power of 6 is the same thing. So 4 over 5 to the power of 6, as we saw there. Surprise boxes. So there's a total given. We don't need any orange again. Okay, we don't need any orange in a few parts of this question. All right, so 3 of 10 is one part. No orange, and then the total. So 5 choose 0 is kind of like no orange, isn't it? Because we have 5 potentially. Okay, no orange, right. So, yeah, I'm going to actually not write it like that. I'm just going to do it in the columns. 10, we want 3 of them. We don't want any orange, and over, there's 15 altogether, so 15, choose 3. So that's the total. I'm going to write down 24 over 91, but that came from 720 over 2,730. Take away 0 in each if you want. Simplify it down, and you'll get 24 over 91. That's part C. There's more. So there's part D. Let's have a look. So they have a different flavor. So with 3 flavors, lemon, orange, and strawberry. So to get one of each is, again, I'm going to use my columns here. So 3 choose 1, times 5 choose 1, times 7 choose 1, all over our total. So again, probability, we're going to find a total over 15 choose 3, which is 3 over 13. And then one more question, the probability again, and we see the word given, so we know it's conditional probability. We had at least 2 of 3. No orange, so we'll be going back to that. We had that already. Absolutely, definitely going back to that part. So, not Bayes' theorem, what are we doing here? Conditional probability. So, strawberry given no orange. Rewrite that. This is a formula that you need to know off by heart. Just make sure it's like that. So, strawberry intersection no orange all over. Probability of no orange. Our possibilities here are SSS. Strawberry, strawberry, strawberry. And then, of course, from that, you'll get strawberry, strawberry, lemon, strawberry, lemon, strawberry, lemon, strawberry, strawberry. And the 3 follow-up ones there are the exact same, of course. Order doesn't matter. 7, choose 3 all over. Again, the total. When we're doing probabilities, it's the same total. So 1 over 13 was strawberry, strawberry, strawberry. Let's do the next 3 just as a single calculation. So you've 7 strawberries, so 7 choose 2, times 3 choose 1, all over that total again. So what are we dealing with here? We're doing 2 strawberries and 1 lemon in whatever order. So we get 9 over 65, and add them together, you get 14 over 65. And from there, we're going to use that and it'll be divided by no orange, so that's from our previous question, 24 over 91. Is that right? Let me just check. 14 over 65, yeah. And then divide by 24 over 91, yeah. Just making sure, just check it. Verify it. And so we get 49 over 60. And that is the end of the